A VPC, or a Virtual Private Cloud, is a private subsection of Azure that you control, into which you can place Azure resources such as VM instances. You have full control over who has access to the Azure resources that you place inside your VPC. Azure Virtual Network, or VNet, is the fundamental building block for your private network in Azure. VNet enables many types of Azure resources such as Azure virtual machines to securely communicate with each other, the internet, and with on-premises networks. VNet is similar to a traditional network that you'd operate in your own data center, but it brings with it additional benefits of Azure's infrastructure such as scale, availability, and isolation. The key scenarios that you can accomplish with a virtual network include communication of Azure resources with the internet, communication between Azure resources, communication with on-premises resources, filtering network traffic, routing network traffic, and integration with Azure services. When you create your virtual network, you also define an IP address range that the VPC can use, and this is done in the form of a CIDR block, which stands for Classless Interdomain Routing. An IP address is used to identify resources over a network. There are two types of IP addresses, public and private. Public IP addresses are the ones that are accessible via the internet. It is your unique IP across the globe. Private IPs, on the other hand, are the ones used within local networks for identification of resources locally. Beyond that, you also have two different protocols, IPv4 and IPv6. We're not going to go into the details of those just yet. You should just understand that these are two different versions of Internet Protocol. Let's take a look at subnets. A subnet, which is shorthand for subnetwork, is a subsection of a network. Generally, a subnet includes all of the computers in a specific location. Let's understand this using the neighborhood analogy, where houses represent computers, and all houses on the same street in a neighborhood would then be a subnet within that neighborhood. There are two types of subnets, public and private. We'll be looking at those in detail later down the road.
Virtual networks is one of the many networking resources offered by Azure. An Azure Virtual Network is a representation of your own network in the cloud. It is a logical isolation of Azure Cloud dedicated to your subscription. So first things first, you can search for virtual networks from the search bar above, or you can just click on the quick links available on the front page. Click on Create so the virtual network creation wizard pops up. First, you need to choose your subscription and your resource group. Then, you need to choose a unique name for your virtual network. I'll just choose Skill Curb Virtual Network. Then, select a region for my virtual network. Make sure that you select the region that you normally use. Then, let's go to the next tab, that is IP addresses. I'll just edit the address space here. I'll add 10.0.0.0/24. And then I'm going to add a new subnet here. The new subnet will have the IP range of 10.0.0.0/25. You can also choose to associate a NAT gateway here with the subnet. A NAT gateway is a network address translation service. It is basically used so that the instances in a private subnet can connect to services outside your VPC, but external services cannot initiate a connection with those instances. I'll just leave it empty for now because I don't already have a NAT gateway enabled. Click on Add, and the next section we have is security. Let's just go through all these options quickly, but we're not going to use them for now. Azure DDoS protection enables you to protect your Azure resources from distributed denial of service attacks with always-on monitoring and automatic network attack mitigation. Azure Firewall is a managed cloud-based network security service that protects your Azure virtual network resources. But I'll just leave it like this and click on Next. The next tab is Tags. I'll just add a dummy tag here and click on Next. Here we can review all the information we just put in and then click on Create. Once the validation is completed, the deployment will start. I'll just pause the video until the deployment is finished because it can take a minute or so. Now let's go to our deployed resource. Here we can see the various properties of skill curve VN. We can see all the capabilities that this virtual network can do. But now I'll just go into the subnets portion and add a new one here. I'll name it subnet 1. I'll choose the IP range of 10.0.0.128/25. Here again I can add a NAT gateway and a network security group if we already have it, but I don't have one, so I'll just click on save. Now my virtual network contains two different subnets. I can choose to associate these subnets with a network security group, virtual machine, and various other resources. I'll just quickly show you how can I associate this virtual network and its subnets to a virtual machine. So let's go back and create a new virtual machine. I will just quickly go through all the settings. I'll just fill in all the required fields. We'll not be focusing on how to create this virtual machine here. So I'll just go straight to the networking section. As we can see, Azure has already added our virtual network that we just created here. I do not need to change anything here. If we don't see our virtual network here already selected, I can just select the new virtual network from the drop down. I will see it there if it is in the same region as my virtual machine. Now let's just finish creating this virtual machine. Now I'll just quickly show you how you can add a virtual network gateway to your new virtual network. I will not create a new network gateway as it is a long procedure. I'll just show you how you can do that. Just search virtual network gateways and click on create. Fill in all the information you need and select your virtual network, but just make sure to use the same region as your virtual network and select your subnet from the IP range here. I'll just cancel it for now because we're not making a new virtual network gateway. I just wanted to show you how you can do that. Now before ending the lab, it's good practice to delete all the resources you made that you no longer need. So I'll just click on the deployment and click on delete deployment altogether. It will delete all the new resources that were made during this deployment. You can select each resource one by one and delete it. You can also select the resource group and delete it to delete all the resources associated with that resource group.
Load balancing refers to evenly distributing load or incoming network traffic across a group of back-end resources or servers. The Azure Load Balancer operates at Layer 4 of the Open Systems Interconnection or OSI model. It's the single point of contact for clients. The load balancer distributes inbound flows that arrive at the load balancer's front end to back-end pool instances. These flows are according to configured load balancing rules and health probes. The back-end pool instances can be Azure virtual machines or instances in a virtual machine scale set. A public load balancer can provide outbound connections for virtual machines inside your virtual network. These connections are accomplished by translating their private IP addresses to public IP addresses. Public load balancers are used to load balance internet traffic to your VMs. An internal or a private load balancer is used where private IPs are needed at the front end only. Internal load balancers are used to load balance traffic inside a virtual network. A load balancer front end can be accessed from an on-premises network in a hybrid scenario. With Azure Load Balancer, you can scale your applications and create highly available services. Load Balancer supports both inbound and outbound scenarios. Load Balancer provides low latency and high throughput and scales up to millions of flows for all TCP and UDP applications. The key scenarios that you can accomplish using the Azure Standard Load Balancer include load balancing internal and external traffic to Azure virtual machines, increasing availability by distributing resources within and across zones, by configuring outbound connectivity for Azure virtual machines, by using health probes to monitor load balanced resources, by employing port forwarding to access virtual machines in a virtual network by public IP address and port, by enabling support for load balancing of IPv6, by the standard load balancer that provides multidimensional metrics through Azure Monitor. These metrics can be filtered, grouped, and broken out for a given dimension. They provide current and historic insights into performance and health of your services. Insights for Azure Load Balancer offers a pre-configured dashboard with useful visualizations for these metrics. Resource health is also supported. You can load balance services on multiple ports, multiple IP addresses, or both. You can move internal and external load balancer resources across Azure regions. And you can load balance TCP and UDP flow on all ports simultaneously using HA ports. VPN Gateway sends encrypted traffic between an Azure virtual network and an on-premises location over the public internet. You can also use VPN Gateway to send encrypted traffic between Azure virtual networks over the Microsoft network. A VPN gateway is a specific type of virtual network gateway. Each virtual machine can have only one VPN gateway. However, you can create multiple connections to the same VPN gateway. When you create multiple connections to the same VPN gateway, all VPN tunnels share the available gateway bandwidth. Let's begin by understanding the difference between a virtual network gateway and a VPN gateway. A virtual network gateway is composed of two or more virtual machines that are automatically configured and deployed to a specific subnet that you create called the gateway subnet. The gateway VMs contain routing tables and run specific gateway services. You can't directly configure the VMs that are part of the virtual network gateway, although the settings that you select when configuring your gateway impact the gateway VMs that are created. When you configure a virtual network gateway, you configure a setting that specifies the gateway type. The gateway type determines how the virtual network gateway will be used and the actions that the gateway takes. The gateway type VPN specifies that the type of virtual network gateway created is a VPN gateway. This distinguishes it from an ExpressRoute gateway, which uses a different gateway type. A virtual network can have two virtual network gateways, one VPN gateway and one ExpressRoute gateway. When you create a VPN gateway, gateway VMs are deployed to the gateway subnet and configured with the settings that you specified. This process can take 45 minutes or more to complete, depending on the gateway SKU that you selected. After you create a VPN gateway, you can create an IPsec IKE VPN tunnel connection between that VPN gateway and another VPN gateway, which is a VNet to VNet connection, or create a cross-premises IPsec IKE VPN tunnel connection between the VPN gateway and an on-premises VPN device, which we would call site-to-site. You can also create a point-to-site VPN connection, which is VPN over OpenVPN IKEv2 or SSTP, which lets you connect to your virtual network from a remote location, such as from a conference or from home. Azure Application Gateway is a web traffic load balancer that enables you to manage traffic to your web applications. Traditional load balancers operate at the transport layer, which is the OSI layer for TCP and UDP, and route traffic based on source IP address and port to a destination IP address and port. Application Gateway can make routing decisions based on additional attributes of an HTTP request. For example, URI path or host headers. For example, you can route traffic based on the incoming URL. So if /images is in the incoming URL, you can route traffic to a specific set of servers known as a pool, configured specifically for images. Or if the /video is in the URL, that traffic is routed to another pool that we can say is optimized for videos. A content delivery network, or a CDN as we call it, is a distributed network of servers that can efficiently deliver web content to users. CDNs store cached content on edge servers in point-of-presence or POP locations that are close to end users to minimize latency. Azure Content Delivery Network offers developers a global solution for rapidly delivering high-bandwidth content to users by caching their content at strategically placed physical nodes across the world. Azure CDN can also accelerate dynamic content, which cannot be cached, by leveraging various network optimizations using CDN POPs. For example, route optimization to bypass border gateway protocol. The benefits of using Azure CDN to deliver website assets include better performance and improved user experience for end users, especially when using applications in which multiple round trips are required to load content, and in large scale to better handle instantaneous high loads, such as the start of a product launch event. And lastly, in the distribution of user requests and serving of content directly from edge servers so that less traffic is sent to the origin server. Let's take a look at how Azure CDN works. So on the first step, we have a user, Alice, who requests a file, which is also called an asset in this case, by using a URL with a special domain name such as endpoint.azureedge.net. This name can be an endpoint host name or a custom domain. The DNS routes the request to the best performing POP location, which is usually the POP that is geographically closest to the user, who in our case is Alice. Now on the second step, we find that if no edge servers in the POP have the file in their cache, the POP requests the file from the origin server. The origin server can be an Azure Web App, Azure Cloud Service, Azure Storage Account, and even any publicly accessible web server. And then once it has that, we come over to step 3. The origin server returns the file to an edge server in the POP. And now once that edge server has that file, we come to step 4. An edge server in the POP caches the file and returns the file to the original requester, who in our case is Alice, and the file remains cached on the edge server in the POP until the time to live or TTL specified by its HTTP headers expires. If the origin server didn't specify a TTL, the default TTL is 7 days. Additional users can then request the same file by using the same URL that Alice used and can also be directed to the same POP. This can be seen in step 5. And then if we take a look at step 6 now, if the TTL for the file hasn't expired, the POP edge server returns the file directly from the cache. This process results in a faster and more responsive user experience. ExpressRoute lets you extend your on-premises network into the Microsoft Cloud over a private connection with the help of a connectivity provider. With ExpressRoute, you can establish connections to Microsoft Cloud services such as Microsoft Azure and Microsoft 365. Connectivity can be from any to any IP VPN network, a point-to-point Ethernet network, or a virtual cross-connection through a connectivity provider at a colocation facility. ExpressRoute connections don't go over the public internet. This allows ExpressRoute connections to offer more reliability, faster speeds, consistent latencies, and higher security than typical connections over the internet.